科學界有一個法則，就係最簡單嘅問題通常最難解答。例如宇宙點樣誕生？事實上喺好耐以前，科學界根本冇工具去解答宇宙起源呢個問題。不過喺過去100年，人類得到一連串突破，透過觀察、決心，加上一啲運氣，我哋終於可以破解呢個重大嘅宇宙之謎。
This was real astronomical gold.
今集我哋會重演一啲科學家最著名嘅發現，同埋佢哋最偉大嘅實驗。
30,000 kilometers per second.
我哋會由宇宙最巨型嘅物體，去到最細緻嘅物質，利用人類有限嘅知識，回到從前，重塑宇宙嘅起源。
The moment 1 millionth of a second after the universe sprang into existence. This is a time before matter itself has formed in any way that we would recognize it. It's as close as we can hope to get to creation, to the beginning of time, the beginning of the universe itself.
真係好難想像，科學界用咗幾百年去想出一套理論，解釋宇宙起源。令人驚訝嘅係，呢個問題原來係好簡單而且基本。
There's something quintessentially human about asking the question, where does all of this come from? Perhaps because it's a deeper, more fundamental version of where do I come from?
不過喺人類史上好長一段時間，呢個睇嚟簡單嘅問題，只係透過宗教去解答。
It wasn't until the middle of the 20th century that science built a coherent and persuasive creation story of its own. It was a story based on theory, predictions, and observation. A story that could finally explain what had happened at the very beginning of time, the beginning of the universe itself.
喺大約100年前，如果科學家談論宇宙嘅生命，會認為宇宙係永恆、無限而穩定㗎，冇開始亦都冇終結，所以根本唔會諗有關宇宙起源嘅問題。不過到咗20世紀初，呢個想法開始改變，新發現推翻舊有嘅想法，為有關宇宙起源嘅問題鋪路。有一個現象改變咗我哋對宇宙大小嘅睇法。呢個觀察開始於天空上一個謎團。20世紀初，當時大家都知道太陽系係處於一個銀河入面。
Every single star we can see in the sky with the naked eye is within our own galaxy. And until the 1920s, all these stars, this single galaxy was the full extent of the entire universe. Beyond it was just an empty void.
但原來天空上面仲有一啲物體，只不過係肉眼睇唔到，睇落去好唔同。而最明顯嘅就係仙女座。
You can find Andromeda if you know where to look. So if you start from Cassiopeia, those 5 stars shaped like a sideways letter M, if you move across from the point, one of the points of the M, and slightly up is where you should find it. Now, I'm going to use my binoculars to help me in the first instance. And if I zoom across, yep, there it is. You can tell it's not a star. I mean, it's basically a very faint smudge stuck between those two stars. That's it straight up there. That's M31, the Great Andromeda Nebula. Now, they were called nebulae because they had this smudgy, sort of wispy, cloudy nature. In fact, the word nebula derives from the Latin for cloud.
呢啲隱約嘅物體散落夜空之中，用望遠鏡睇就會見到好多星雲，比星際氣體複雜得多。睇落去好似有好多行星，咁樣引申出兩個可能性。
Were these stellar nurseries places where stars were born and therefore residing within our own galaxy? Or, much more profoundly, were these beautiful, enigmatic objects galaxies in their own right, sitting way outside the Milky Way?
第二個可能性嘅含義好廣泛。如果係真嘅話，就會馬上徹底改變我哋對宇宙大小嘅睇法。
Here was an opportunity for an ambitious astronomer to make a real name for themselves. Perhaps someone with a really big telescope. Step forward this man, Edwin Hubble, a man from Missouri. Although, if you'd ever met him, you'd never have guessed, because he developed this weird persona, a pipe-smoking tea drinker with a very affected, aristocratic English accent. Hubble is probably the most famous astronomer ever, not least because of his consummate skill at self-promotion, but also because of the incredible measurements he would make.
喺哈勃嘅時代，一提到觀察同埋新嘅發現，大細就好重要。今時今日，呢個係世界上最強嘅光學望遠鏡——加那利大型望遠鏡，主鏡嘅直徑超過10米，比哈勃嗰陣擁有嘅望遠鏡大得多。
In September 1923, Hubble was working at what was then the biggest telescope in the world, the 100-inch Hooker telescope at the Mount Wilson Observatory, perched on top of the high Sierra Mountains overlooking Los Angeles in California. He was using the telescope to study one of the most prominent nebulae in the sky, the Andromeda Nebula.
即係我剛才睇到嗰片星雲。就喺哈勃觀察星雲時，有一顆好特別嘅行星引起佢嘅注意。呢顆行星可以揭示仙女座嘅真正特質。我而家正係準備用呢個望遠鏡去揾呢顆行星。
This is the control room of the GTC, and tonight they've pointed the telescope at Andromeda, and they're going to take a picture of it. It takes about a minute for the exposure to give you a clear enough image.
That's right. Takes a minute, yeah. Now the picture is finished, so we are going to open it.
Okay, so this is Andromeda here.
That's Andromeda, that's right.
And now this is Hubble's original plate. Yeah. Right, now Hubble's star is down here in this corner. Can you find it in your image?
Yeah, if you take the image and you compare it, you will see that we don't see that one. What we see is the edge of the galaxy, so we have to go a little bit further away.
Oh, I see. So all this is just the edge?
That's the edge.
I was assuming it was the center of the galaxy.
No.
It just goes to show how much more resolution your telescope can get.
Yes.
Okay, so can we see that particular star?
Yeah, in order to find that particular star, because it's so faint, we have to look for reference which are brighter. And in this case, you will see 4 stars in here, which are these 4 stars, and the star Hubble found. will be this one here.
That's it. That's
That
Hubble's.
tiny star is the one that Hubble found.
That's amazing. And are you able to get a magnitude for that star?
Yeah, we have to do a little bit of processing on the image, but we are able to get it.
Okay. Hubble had found his star. He knew it was special because he compared his plate with others taken over previous nights. And he noticed that his star changed in brightness. Some nights it was brighter, some nights it was dimmer. He realized this is a variable star, and he saw the significance of it. He could see that this was real astronomical gold.
哈勃揾到嘅係造父變星。造父變星好特別，因為透過研究光度改變，天文學家就可以計算出距離有幾遠。
Hubble's Cepheid was the first to be discovered in a nebula, so he knew that if he could measure its period, he'd be able to work out its distance from us.
於是哈勃決心好精細咁量度呢顆行星光度嘅變化。
It's not hard to imagine how exciting this must have been for Hubble. At his fingertips was the opportunity to resolve a fundamental yet simple question. Was this nebula within the Milky Way or beyond it? The answer would reshape our knowledge of the universe. Hubble measured the luminosity or brightness of his star over many nights and plotted this curve here. Now, when we measured it tonight, we found it had a value of 18.6. And I know because they measured it last night to be slightly dimmer that it falls on this side of the curve. But more important is the period, the time in days from peak brightness to peak brightness. Hubble measured this to be 31.415 days. This is the critical measurement.
得到呢個數據同埋明顯嘅亮度之後，哈勃計算出地球同仙女座星雲嘅距離。
It was immediately apparent that this star is very far away. But when Hubble did his calculation, he worked out that it was 900,000 light years away, making this star the most remote object ever recorded.
作為公司最高領導人，必須具備過人素質。要成為商業精英，到底要付出幾多心血？打開社長不為人知嘅日程表，成功之道盡在眼前。社長作戰室，星期3晚8點半，無線財經資訊台。
借呢筆錢應該夠結婚用。
嚇！你又知我哋要借咁多
？30萬係香港人結婚嘅平均開支，應該夠㗎啦。冇嘢解決唔到，221財務，中局借錢梗要還，咪俾錢中介。
唔化妝想素顏示人冇可能，顛覆傳統護膚概念，全新 Neutrogena 素顏霜，一抹膚色瞬間提亮，5重亮白因子，打造零妝光感素顏，唔化妝都透亮。Neutrogena 光澤 Power Up， 紅光紅外線深入肌底，7天淡化色斑。
無壓力嘅睡眠由 Temper 床褥開始 ，Temper 舒壓物料有助減少睡眠轉身次數。源於美國太空總署研發嘅舒壓物料，助你輕鬆進入深層睡眠。來自丹麥嘅 Temper 床褥，來自丹麥嘅 Temper 低至5折，千祈唔好錯過。
先生，等我幫你啊！
可以轉紅米，健康啲喎。
小心熱，慢慢食。
企喺你角度，用心諗多步 ，feel good 就係大快活。
農夫大鬧西遊，爛 gag 由天庭玩到出宇宙，超無聊抵死爆笑嘅全新超短網劇《西遊之法界與沙僧》，即上Big Big Channel睇啦！
法國巴黎銀行特約法證工房，逢港股交易日上午9點45分，無線財經資訊台。
咁樣只代表一個意思：仙女座唔單止係一個獨立銀河，仲離開地球嘅銀河好遠好遠，而其他螺旋形星雲亦係好遙遠嘅銀河。
It was a moment in human consciousness when the universe had suddenly and dramatically got considerably bigger. With this observation, Hubble had redrawn the observable universe.
雖然呢個發現冇直接挑戰穩定宇宙嘅想法，不過就粉碎咗長久以嚟嘅假設，開啟咗其他更重大謎團嘅可能性，就好似宇宙起源呢個問題。
Into this profoundly expanded cosmos strode someone who would, without realizing it, provide the tools to unlock that secret. This guy. A story as great as one that explains the origins of the universe would somehow feel wrong without involving a scientist as great as Albert Einstein. And so, of course, it does, because it was Einstein who provided the theoretical foundations needed to study the universe and effectively invent the science of cosmology.
100年前，愛因斯坦提出咗相對論。顛覆整個物理學，令我哋對呢個世界有全新嘅理解。佢提出巨型物體，例如行星同行星，令時空扭曲，從而形成重力。當時相對論係好革新嘅學說，愛因斯坦係一個特立獨行嘅人。唔理會傳統，只會跟隨自己嘅直覺而行。
One of his lecturers once told him, "You're a smart boy, Einstein, a very smart boy, but you have one great fault. You do not allow yourself to be told anything." Of course, it was this very quality that would allow him to change the world of physics, and of course to mark him out as one of the greatest thinkers of the 20th century.
1917年，愛因斯坦將相對論應用喺整個宇宙。
By following the logic of his theory, he arrived at something rather unsettling. The combined attraction of gravity from all the matter in the universe would pull every object in the cosmos together, beginning slowly but gradually accelerating until gravity would ultimately and inevitably lead to the collapse of the universe itself.
不過同幾乎所有人一樣，愛因斯坦相信宇宙係永恆而靜態㗎，絕對唔係唔穩定，冇可能會自行崩解。不過方程式顯示出嚟嘅結果就啱啱相反。
In order to prevent the demise of the universe and keep everything in balance, he adds this in his equation, lambda, or the cosmological constant. It's a sort of made-up force of anti-gravity that acts against normal gravity itself. Now, he had no evidence for this, but it helped ensure that his equations described a stable universe.
雖然宇宙嘅起源秘密就喺掌握之內，但係愛因斯坦就係唔肯或者唔願意去接受自己方程式所帶出嘅含義。
With hindsight, it seems remarkable that Einstein did this. I mean, here was a man who had revolutionized science by rejecting conventional wisdom. And yet, he couldn't bring himself to trust his own theory. He felt compelled to massage his equation to fit the established view. He even admitted that the cosmological constant was necessary only for the purposes of making a quasi-static distribution of matter, basically to keep things the way they were. Whatever his reasons, this little character lambda would return to haunt him.
因為喺阻止愛因斯坦理解個中含義嘅時候，佢嘅想法就為另一個人開路，提出宇宙起源嘅理論。佢係一個年輕嘅大學理論物理學兼職講師。
His idea was so radical, it shocked the world of physics and split the scientific community. He started an argument that wouldn't be resolved for half a century. His name was Georges Lemaitre. Now, the eagle-eyed might spot the dog collar. In fact, he was both a physicist and an ordained priest. Of this apparently curious dual role, Lemaitre said, there were two ways of pursuing the truth. I decided to follow both. And using Einstein's theory of relativity, he developed his own cosmological models.
勒梅特嘅模型描述宇宙根本唔係靜態㗎，喺好多銀河激烈互相排斥下，其實正係不斷擴大。
Furthermore, Lemaitre saw the implications of this. Winding back time, he deduced that there had to be a moment when the entire universe was squeezed into a tiny volume, something he dubbed the primeval atom.
基本上，呢個就係後嚟被稱為宇宙大爆炸理論嘅最初講法，即係宇宙創造嗰一刻。
These were revolutionary ideas, and so he published them in the Annales de la Société Scientifique de Bruxelles, where they were promptly ignored by the scientific community.
於是佢專程去布魯塞爾，嘗試爭取支持。
The 1927 Solvay Conference, held here in Brussels, was probably the most famous and greatest meeting of minds ever assembled. But for our story, the most significant meeting didn't happen here. It wasn't planned and happened away from the conference.
就喺呢度，當時寂寂無名嘅勒梅特就喺呢個公園接觸世界上最有名嘅科學家愛因斯坦。
Here, finally, was his chance to explain his idea about an expanding universe to the very person whose theory he'd used to derive it. You can only imagine Lemaitre's trepidation as he approached. If Einstein endorsed his radical idea, then surely it would be accepted. Surely this brilliant mind, this titan of physics, this deeply original thinker would see the merits of his theory. But after a brief discussion, Einstein rejected his idea out of hand. According to Lemaitre, he said, "Vos calculs sont corrects, mais votre physique est abominable." As far as Einstein was concerned, his maths might have been correct, but his understanding of how the real world worked was, well, abominable.
愛因斯坦再一次否定動態宇宙嘅想法。
Lemaitre's paper should have ignited science, but without the backing of such a huge and influential figure as Einstein, his groundbreaking idea was doomed to be quietly forgotten. Unless some observation or evidence showed up to support the idea of an expanding universe. Edwin Hubble here was riding high after his discovery that proved there were galaxies outside of our own. He was feted by Hollywood glitterati, a guest of honor at the Oscars, and with access to the world's most powerful telescope, he was ready for his next challenge.
當時哈勃知道一啲唔尋常嘅情況，有人觀測到好多銀河好似正係移走，佢離我哋越嚟越遠。不過冇人知道點解。於是喺1928年，世界上最有名嘅天文學家將注意力轉移到呢個全新嘅宇宙謎團上，並且開始量度呢啲銀河移動嘅相對速度。
To measure the velocity that a galaxy was receding from us, Hubble used something called redshift. Now, it's not a perfect analogy, but the effect is similar to one most of us are familiar with in sound. The pitch of a car engine as it approaches us is higher because the sound waves are compressed, but the pitch drops lower as the car recedes because the sound waves are stretched. The effect is similar with light waves. As the source of light moves towards us, the observed wavelength is squashed towards the violet or blue end of the spectrum. But if the source is moving away from us, the wavelength is stretched towards the red end of the spectrum, or redshifted in the parlance of astronomers. And the greater the velocity the object is receding, the greater the redshift.
團結就係力量。
真係夾咗2萬蚊啫，唔係每人2萬，係真係得2萬。邊個唔識為拉個人入嚟？有錢出錢就有力出力。
唔怕辛苦，力量變得更強。
朝早7點喺觀塘地鐵站企喺度派傳單啦，夜晚咧就去各大屋邨停車場。
相對論，星期4晚8點半，無線財經資訊台。
問我講做乜辦關公啊？我有災難，講錯嘢。我爭人幾條數10幾萬，要關二哥保佑。揾 Money SQ 私人貸款嘛，大額整合，將債務集中處理，年利率仲低至3.8%。Thank you。中國借錢梗要還，咪俾錢中介。
Sealy Mattress. Support you trust, comfort your love. Now, up to 50% off.
思月，日本 No.1 一案染髮，仲係連續11年，證明佢真係 work。簡單一案，濃密乳霜緊貼髮絲，連髮線都染得咁出色。思月乳霜。
法國巴黎銀行特約法證工房，逢港股交易日上午9點45分，無線財經資訊台。
拍戲咁多年，乜嘢角色我都係用心去演，冇嘢難倒我。
自叻係你啦，阿爸。
真係不講。
爹哋，
係咪好戲啊？
你做咩嚇人啊？
傻女，有馬伯良安宮牛黃丸旁身，點會有事啊？馬伯良安宮牛黃丸，養心安神，維持心臟健康。健康係我對屋企人嘅承諾，我信馬伯良安宮牛黃丸。
無論你係男定女，中意男仔定女仔，都要注意。近年感染艾滋病病毒嘅人有年輕化嘅趨勢，每3個新感染者就有1個細過29歲，當中有接近80%係經由性接觸傳染嘅。保護自己要有一套，如果有懷疑，即刻打愛滋熱線，預約做免費嘅愛滋病病毒抗體測試。
TVB 周刊娛樂生活資訊全新放送，流行經典50年，注入新力量，延續經典。冒險王衛斯理本地科幻經典再現熒幕，上食同意繼續橫掃亞洲獨特美食。TVB 節目食譜全面放送 ，TVB 周刊出版咗啦。
喺助手黑馬森嘅幫助之下，哈勃花咗1年時間，好小心咁量度銀河嘅紅移。我而家就有機會用呢個望遠鏡做同一樣嘢。
Okay, Massimo, have you found a galaxy for me?
Yes, I found this galaxy.
So how far away is this?
It is approximately 430 megaparsec far.
So if you convert that to light years, so 430 times 3.26, so it's about 1.5 billion light years away.
Yeah.
Okay. Hubble needed to measure the average light coming from the galaxy in order to get a spectrum so that he could calculate the redshift. Now, Hummerson did this by exposing a photographic plate, and it took him a whole week to collect enough light to get the spectrum. But here at the TNG, the Galileo telescope, they use instead a very sensitive chip that can do this much more quickly. How long does it take for you to get a spectrum?
Approximately 10-15 minutes.
So, 10 or 15 minutes exposure compared with a week back in Hubble's time. Far more powerful than anything they had back then.
No,
it's done.
The spectra is quite good.
Okay, so this is the raw spectrum that's
Yes.
taken. Is there a particular emission line here that you will use as your reference to measure the redshift?
Yeah. Here, for example, you have an emission line, but to obtain a real spectra, you have to clean it to obtain the final one.
This is the cleaned up version of that.
Yes, of that.
So this is the actual
Emission
lines from the galaxy.
Yes.
And this one below, I guess, is the reference.
The reference, so correct, of a galaxy with a redshift 0.
Okay, so one that isn't moving away relative to us.
Yes.
And so it's very clear here, if you compare the top one with this one, every emission peak is shifted.
Is shifted in the red. The reference line for his sample is H alpha. And from this, you can compute the redshift of this galaxy.
And can you work out from that how fast the galaxy is moving away from us?
In principle, you can obtain this.
Okay, so what's the formula?
The formula is the difference between the rest wavelength and the observed wavelength divided by the reference wavelength and multiplied by C. This is the Doppler effect.
Let's see if we can do that roughly.
Yes.
Okay, so this is about
7, 2, 0, 0, approximately.
Okay.
Minus 6, 5, 6, 3.
3,
Okay.
over
6, 5, 6.
3.
Yeah.
And that's the fraction of the speed of light.
Yes.
Okay, so I might as well do this. I should do it with my calculator. So 7200, 6563. So it's 7, 3, that's a 6. Okay, so then that we divide by 6563. Okay, so it's roughly 0.1 the speed of light. 0.1 c. So it's about 30,000 kilometers per second. Yes?
Correct.
Thank you. Okay, I'm actually quite pleased with my maths here because I was under pressure. So this galaxy is 1.5 billion light years away from the Milky Way, and it's moved from the redshift. We've worked out it's moving away from us at 1/10 of the speed of light. That means it's moving away from us at 30,000 kilometers per second. Boom. Science.
哈勃一計算到銀河移走嘅速度之後，就計算銀河嘅距離。
Once Hubble had both his measurements, he could start plotting them on a graph of velocity against distance. Now, he made 46 different measurements, and when he put them on the graph, he noticed a pattern emerging. He could draw a line through all these points. Each one of them is an individual galaxy. He noticed a connection between the velocity and the distance of a galaxy. In fact, the further away it was, the faster it was moving away from us.
喺一個穩定嘅宇宙入面，銀河嘅移動速度應該係冇模式㗎。銀河間嘅距離同移動速度應該唔會有清晰嘅關係。不過哈勃嘅圖表顯示，宇宙不斷咁膨脹，對宇宙起源就有好深遠嘅含義。
What this means is that it's not just that the galaxies are all speeding away from us and from each other, but if you could wind the clock back, there would have been a time when they were all squeezed together in the same place. Here finally was the first observation, the first piece of evidence that Lemaitre's idea of a moment of creation, of a universe evolving from a Big Bang, might be correct. Thanks to Hubble's work,
Georges Lemaitre, the unknown Belgian cleric, the theoretician without proper international credentials, the man whose physics Einstein called abominable, was belatedly rightly recognized for his bold theory.
最重要嘅係物理界最有名嘅人，終於認同呢一個革命性想法。
In 1931, on a visit to Hubble's observatory, Einstein publicly endorsed the Big Bang expanding universe model. The redshift of distant nebulae has smashed my old construction like a hammer blow, he said. Einstein dropped the cosmological constant. He even wrote to Lemaitre, "Ever since I introduced the term, I have had a bad conscience. I am unable to believe that such an ugly thing should be realized in nature." It must have been quite an absolution for Lemaitre. Having been practically cast out into the scientific wilderness, he was now firmly at the center of a cosmological revolution.
宇宙大爆炸嘅想法終於有進展。不過，雖然得到愛因斯坦嘅認同同埋哈勃嘅觀察支持，爭論仍然未完結。
There were still significant objections if the idea of a Big Bang was to be widely accepted. A scientific theory of creation isn't just about explaining the expansion of the universe. There are more profound issues to resolve.
問題係宇宙大爆炸理論出現後，引發更多疑問。例如，如果宇宙係由一點爆發出嚟，咁所有物質嚟自邊度呢？再諗深一層，呢個新理論必須解釋得到物質係點樣形成。
If you were to ask someone what the most common elements were, an atmospheric scientist might say nitrogen. After all, it makes up more than 3/4 of the atmosphere. Geologists might say silicon or iron or oxygen, which all seems very quaint and Earth-centric and really rather parochial.
天文學家之後開始研究太陽，從行星嘅誕生同演化，了解各樣物質嘅形成過程，嚟填補理論嘅不足。
世界之大，造物之奇，無數絕美秘景，人生不能錯過。人民風俗文化，絕嶺神奇景觀。繼續浪跡天涯，一同探索。秘境不思日三，星期六晚6點，無線財經資訊台。
手術切除後，醫生證實個瘤係良性，我真係鬆一口氣。好彩買危疾連良性瘤都有得賠，收到支票嗰刻係額外嘅好消息。仲有個好消息。呢餐我請，
保誠守護健康危疾加護保，危疾賠償包括切除良性腫瘤。英國保誠用心聆聽，更知你心。
我哋呢代越住越細，
有家長 TMF 幫你訂做家私就冇問題啦。
撳着個掣就睇實晒，生產進度隨時 check 得到。30日未夠就送到，隔離瞓廳家私未整好。
咪住，有第三者。
原來係佢貼身服務跟進做晒，
匠心、
安心、窩心，家長 TMF。
整蛋糕食材係最緊要。啲奶邊度嚟㗎？
澳洲嚟嘅。生果大部分係美國嚟嘅。
咁啲朱古力咧？
係比利時同法國嚟嘅。
呢個係
美心金芒傾心蛋糕嚟嘅。
啖啖芒果肉真係新鮮，美心西餅。
你以為非法盒子淨係睇節目咁簡單？投
防惡意軟件嘅入侵，有人會知道你嘅銀行戶口，仲睇埋你嘅私隱，甚至勒索你。使用冇管制嘅非法盒子，你就等於赤裸裸暴露喺賊人嘅視線內。保護私隱，使用正版。海外觀眾要睇 TVB 節目，請上 TVB Anywhere 官網購買，或同特約經銷商聯絡。你仲敢睇？
低啲啊！低啲啊！再低啲！低啲！低啲！Yes！ 冇得再低啦，點低啊？唱唔到啦喎！終於俾我睺到英鎊嘅低位啊！
呢個價我一早 set 定㗎啦，買埋添啦！
而家用 City Mobile App 買外幣，即享無上限0% 差價。
開戶口仲送你高達5萬里數。
City Mobile App is a bank in my hand。
爺爺陪我玩啦，要交管理費。
好貴喎，老親又嫁女，年紀大機器壞，退休冇收入，點應付咁多開支？退休生活有年金，自製長糧，至安心。
香港按揭證券有限公司查詢熱線25125000。
There are still very big questions to resolve about the beginning of the universe. Questions like, where did all the matter itself come from? And how do you get something from nothing? The answers to these questions lie further back, hidden behind the curtain of the CMB. Their secrets lie in the primordial universe, within the very first second of its existence.
呢度就係我哋理解宇宙嘅地方。而家科學界其中一個最先進嘅實驗室，方法唔係仰望星空，而係望去瑞士同法國邊界。講得更精準就係歐洲核子研究組織，嗰度有全球最先進嘅粒子加速器，稱為大型強子對撞機。
Now, you might be wondering what a particle accelerator has to do with the early universe, because the connection between the two is far from obvious. The thing to remember is that when the universe was very young, it was much smaller. And so all the matter, everything that makes up the stars, the galaxies, black holes, all had to be confined into a much smaller space. At that stage, the universe was phenomenally hot, and more significantly, its energy density was very high.
就喺呢個時候，首批物質開始形成。強子對撞機未複製到呢個過程，不過就可以俾我哋研究到呢啲基本粒子嘅特質。
Once a year, the LHC stops its normal business of colliding beams of protons and instead uses much more massive particles to create collisions with energies more than 80 times greater than that produced from two protons. They do this by accelerating atoms of lead, stripped of all their electrons, up to speeds close to that of light, and smashing them together. And that lets us see something pretty special.
正係因為相撞太激烈，喺某一刻可能會誕生出獨特嘅物質。一個唔係原子，甚至唔係中子或者係質子嘅環境，而係夸克、膠子同氫子呢啲名稱特別嘅粒子聚集起嚟，喺宇宙大爆炸100萬分之1秒之後形成，之後就一直被困住。
Down there, underneath that lead shielding, we're recreating a stage in the universe's evolution called the quark-gluon plasma. Now, this is the moment immediately before the quarks become trapped by the gluons to create protons and neutrons, which themselves go on to form the nuclei of atoms. The phrase we use grandly is the confinement of the quarks. To develop the necessary energy, the lead nuclei are passed through a chain of smaller accelerators gradually ramping up the energy until they're finally fed into the largest accelerator on Earth, the LHC. Now, the maximum energy a beam can achieve is directly related to the size of the accelerator, and the LHC has a circumference of 27 kilometers. Now, that means the beams here can achieve an energy of 1,000 tera-electron volts. Now, actually, that's less than you might imagine, because it's equivalent to the energy that a housefly hits a window pane. But the critical difference here is that the energy is concentrated. It's the energy density that's important. The LHC can squeeze all that energy down to a space that's less than a trillionth of the size of a single atom.
喺我哋所知嘅宇宙裏面，冇另一個地方可以咁樣做到。
The two beams of lead nuclei are traveling around the ring in opposite directions. They're meeting deep underneath this control room at the detector. You can see live feed pictures of the detector up on that screen. Now, underneath us, they're traveling at a speed of 99.9998% the speed of light. That means they're covering the full 27-kilometer circumference of the ring more than 11,000 times per second. When the beams reach maximum energy, and we can see up there it says iron physics stable beams, that means they can be crossed, just like in Ghostbusters. At that point, a tiny fraction of the lead nuclei will collide and create a super hot, super dense fireball with a temperature 400,000 times hotter than the center of the sun, and a density that would be equivalent to squeezing the whole of Mont Blanc down to the size of a grape. Looks like a fantastic image there. So can you tell me what we're seeing?
It's amazing, actually, isn't it? It's literally tens of thousands of particles and antimatter particles flying out. This kind of aftermath of this explosion.
Right.
換言之，有顏色嘅粒子軌跡唔係夸克同膠子，而係相撞後所產生嘅夸克膠子電漿。
We have to infer its properties from looking at the debris that flies out. It's a bit like working out how an aircraft works by looking at the debris of a plane crash. That's what we see.
What I find amazing is what we're doing here is trying to recreate that moment in the early universe where the quarks and gluons were all free to float around because the energy was so high. And then it cooled and they stacked together. You're doing the opposite. We're starting with normal matter, smashing it together, and going back to that unconfined state, that plasma.
Yeah, I mean, I like to think of Alice as a time machine. We're actually winding back the clock. And this is the only way that we can study the properties of free quarks, because these quarks have been imprisoned inside particles like protons and neutrons for 13.8 billion years.
That's pretty incredible, isn't it? Finally, after 13.8 billion years, you can set these quarks free, even if it's for a fraction of a second.
Yes.
雖然我哋仲未知道物質點解會出現，研究粒子對撞可以俾我哋向有關嘅問題踏出一步。
What we've just witnessed is the earliest stages of the universe that anyone, anywhere, has been able to observe. It's the closest we've got to the moment of the Big Bang. And let's face it, it's not bad. 1/1,000,000th of a second after the Big Bang itself.
雖然得到呢一啲進展，不過未能夠解答嘅問題仍然有好多。
Beyond this is where some of the deeper mysteries of the universe are hiding. How the four fundamental forces that bind matter together, gravity, electromagnetism, and the nuclear forces, are connected to each other. How the particles that make up matter itself condensed out of a fog of energy. How mass is generated from the force that binds protons and neutrons together. And how the universe itself underwent a super-fast expansion in 1 billion of a second to create the structure of the cosmos.
呢一刻我哋未有方法可以觀察到所有呢一啲現象，只能夠用抽象嘅理論去推測。
If we're ever going to replicate this early stage of the universe's evolution, we're going to need to create considerably higher energies. Frankly, we're going to need to build a bigger collider. And that's a problem. And it's not just one of expense, although it would be phenomenally expensive.
更大嘅問題係要揾到地方去起。
Remember when I said the energy is related to the circumference of the accelerator? Well, the LHC down below me has a circumference of 27 kilometers. It runs beneath the Jura Mountains and straddles both France and Switzerland. In order to look back and observe the universe at this earlier stage, well, we need to build an accelerator with a circumference larger than the orbit of Pluto.